Section 1.3, Trigonometric Functions. In this section, what we're going to talk about is trigonometric functions. If we let xy be a point other than the origin on the terminal side of an angle, then we call this angle theta, in standard position. The distance from the point to the origin is r is equal to the square root of x squared plus y squared. Now this is just your distance formula, or your Pythagorean theorem, taking the square root of both sides. The 6 trigonometric functions of theta are defined as follows, and most of us know this, but we have to think of it in terms of an ordered pair in order to do this section. So again, you have your xy point, and r is the distance from the origin, like we did in the previous section. R is the distance from the origin to that point. So sine of theta is going to be y over r. Cosine theta is going to be x over r. Tangent theta is going to be y over x. And then cosecant is going to be the reciprocal of sine theta. So cosecant theta is going to be r over y. And then secant theta is going to be r over x. And cotangent theta is going to be x over y. So again, you have to think of these in terms of an ordered pair, which is going to be your xy and then your distance r. And if you'll look on page 21 in your book, down at figure number 23, it'll show you what's going on with the angle and the xy and the r. Okay, so if it says to find the values of the 6 trigonometric functions for each angle in standard position having the point 2, radical 3, and negative 2. Well, the first thing I want to do is I want to change 2 radical 3 to a decimal so I'll know how to graph it. And so that's going to be about 3.5. So if we draw this picture, we're going to have an ordered pair at 3.5 and negative 2. So we're here. And just like we did in the previous section, we can draw a ray through this, and that's going to make a right triangle. So we know that the x is 3.5, and we know that the y is negative 2, and then of course r we need to find. So what we can do is we can say r is equal to, and again, it's just the Pythagorean theorem, r squared is equal to x squared plus y squared. But what they did is they went ahead and squared both sides. And so that's the formula that they're using in the book. And so we have r is equal to the square root of x squared, which is going to be, don't use the decimal, that's just a rounding, so use the exact figure, 2 radical 3 squared plus negative 2 squared. And so we'll have r is equal to the square root of 2 squared is going to be 4, square root of 3 squared is going to be 3, so 4 times 3 is going to be 12. Again, 2 square roots of 3 squared. You're going to take 2 and square it, and you're going to take the square root of 3 and square it. So you're going to get 4 times 3, which is going to be 12. Alright, plus 4, so we're going to have r is equal to the square root of 16, which is simply 4. Alright, so now that we know what r is, we can do our 6 trigonometric functions. And again, theta is going to be right here. And so, having theta, we're going to find our 6 trigonometric functions of theta. So we have sine theta, cosine theta, and tangent theta, and then of course we'll have the reciprocals of those. So sine theta is going to be y over r. Y over r. So that's going to be negative 2 over 4, which is the same as negative 1/2. Cosine theta is going to be x over r, so we'll have 2 radical 3 over 4, and then again that can reduce, and so we have the radical 3 over 2. And tangent theta is going to be your y over x. So we'll have negative 2 over 2 radical 3, which is going to be negative 1 over radical 3, and we do need to rationalize that. So we're going to get negative radical 3 over 3. Alright, so now we need to find the reciprocals. So cosecant theta is going to be the reciprocal of sine, so that's going to be negative 2 over 1, or simply negative 2. Secant theta is going to be the reciprocal of cosine theta, so you're going to have 2 over the square root of 3, and then we'll rationalize that, so we'll have 2 square root of 3 over 3. And then cotangent theta is going to be the reciprocal of tangent, and so that's going to give us negative square root of 3. And that's how you find the 6 trigonometric functions for an angle in standard position given a point on its terminal side. Okay, suppose that the point xy is in an indicated quadrant. Decide whether the given ratio is positive or negative. Well, what we have to do is we have to picture in our mind where this ordered pair is and what the x and the r would be, or add the x, the y, and the r would be. R is always going to be positive, so because it's a distance. So if we're in quadrant 2, if we have an ordered pair anywhere in quadrant 2, your x is going to be negative, your r is going to be positive, and so therefore decide whether the given ratio is positive or negative. The negative divided by a positive is going to be a negative. In quadrant 3, which would be here, you're going to have a negative x and a negative y, and so a negative divided by a negative is going to be positive. And then here in quadrant 4, you're going to have a positive x, and r is always positive, so you're going to get a positive. And then in quadrant 1, everything's positive, so you'll get a plus y and a plus r, so this is going to be positive as well. Alright, so what if we're given something like this? It says sketch the least positive angle given an equation of the terminal side of an angle. So this time, instead of having an ordered pair, we actually have a line. Actually, it's going to be a ray because of the domain, and find the values of the 6 trigonometric functions. So what we're going to do is we're actually going to graph this straight line. We're going to graph this straight line. So let's put this in slope-intercept form. So we'll have minus 3x from both sides. We'll have y is equal to negative 3x, and then if we divide both sides by 5, we'll get y is equal to negative 3/5 x plus 0, of course. And so your y-intercept is going to be 0, and we're going to go down 3, and to the right 5. So we're here, and so here is this ray, and technically we do have an ordered pair. That ordered pair is going to be 5, negative 3. And so again, we have our right triangle. Our y is going to be negative 3, and our x is going to be 5. And so we can find those 6 trig functions. R, we need to figure out what r is going to be, of course. So r is going to be the square root of x squared, which is going to be 5, plus y squared, which is going to be negative 3. So r is going to be the square root of 25 plus 9. So r is going to be the square root of 34. Square root of 34. Alright, so sine. Sine theta, again, here is theta. Sine theta is going to be your y over r, so it's going to be negative 3 over the square root of 34. And of course we are going to rationalize that, so we're going to have negative 3 square roots of 34 over 34. Cosine theta is going to be x over r, so we'll have 5 over the square root of 34, which is going to rationalize into 5 square roots of 34. 5 square roots of 34 over 34. And then tangent is going to be negative 3 over 5. Cosecant theta is going to be the inverse of sine, so that's going to be the square root of 34 over negative 3. And then secant is going to be the inverse of cosine, which is going to be the square root of 34 over 5. And then cotangent is going to be the inverse of tangent, and so we'll have 5 over negative 3. Alright, so if you're given a line, you actually need to graph that line, figure out your ordered pair that it's going to go through by using your slope, and then figure out what r is going to be, and then you can find your 6 trigonometric functions. Okay, quadrantal angles. We talked a little bit about quadrantal angles in the previous section. We actually mentioned them briefly. Remember, if you have an ordered pair that's actually on an axis, this is called a quadrantal angle. And so this is called our unit circle, and the reason being is because it's one unit from the origin. So this is going to be our unit circle. And so if we do our quadrantal angles, we come up with this chart. Now you don't have to memorize this chart, and the reason being is because it can be common sense. So for example, for all of these, r is going to be 1. R is going to be 1. The distance from the origin to each point is going to be 1. So we know that sine is going to be y over r. So your y is going to be 0 over 1, which is 0. Cosine is going to be x over r, so you're going to have 1 over 1, which is 1. And then tangent is going to be y over x, so 0 over 1 is going to be 0 as well. And then if you do the inverse of tangent, that puts 0 on bottom, so you're going to have 1 over 0, and that's why it's undefined. And then secant is going to be the inverse of cosine, of course, so the reciprocal of 1 over 1 is just 1. And then cosecant, again, that's going to be 1 over 0, which is undefined. So, again, you don't have to memorize these, but you do need to know, if you're not going to memorize this table, which I don't suggest, what I do suggest, though, is I suggest that you memorize these. Understand what these are. And it does go hand in hand with SOHCAHTOA, if you remember opposite over adjacent and opposite over hypotenuse and things. So how can we use these quadrantal angles to figure out trigonometric expressions really quickly? Well, watch this. Tangent of 0 degrees. Well, tangent of 0 degrees is 0. So this is a number. This is a whole number of 0. Minus 6 times sine of 90 degrees. Sine of 90 degrees is 1. And so you'll have 0 minus 6, which is equal to negative 6. What if we do sine squared 90 degrees? Well, this can be rewritten as sine 90 degrees squared. It's just typical trig terms. We put the squared here, but just understand it's this whole function squared. So sine of 90 degrees is 1. So this is going to turn into 1 squared plus cosine squared of 90 degrees. Cosine of 90 degrees is 0. And so you just get 1. And later on we'll talk about this is a Pythagorean. So if this is going to be any sine squared plus cosine squared theta is going to be equal to 1. Alright, so what about this one? We have 5 sine squared 90 degrees. So we need to do 5 times sine of 90 degrees squared. Well, again, sine of 90 degrees is 1. So that's going to be 5 times 1 squared plus 2 times cosine of 270. Cosine of 270 is going to be 0 squared minus 7 times tangent of 360 degrees. Tangent of 360 degrees is 0 as well. So what we're going to have is 5 plus 0 minus 0, which is 5. Alright, last one. Cotangent of 270 degrees. Cotangent of 270 degrees is going to be 0 plus 8 times cosine of 180 degrees. Cosine of 180 degrees is negative 1 plus 5 times secant of 360. Secant of 360 is 1 squared. So we're going to have 0 minus 8 plus 5, which is going to be a negative 3. So again, you can use these quadrantal angles to easily figure out trigonometric expressions such as this. And like I said, you see me flipping back to this table, but you don't have to memorize this table. It is a quick reference guide, but on the test you won't have this table to look at. So you need to understand this unit circle. You need to figure out, you need to be able to understand how to find each of these using this unit circle. And we can work on that in class. Alright, so what I would like you to do is I would like you to work on these problems on pages 26 and 27 in your book. If you have any questions, bring them into class, and we will certainly work on this in class.